Hey, from West Virginia. So, still, I just can't seem to get this right. But what I can get right, though, is joke of the day. Because I know that you've been waiting. I know you're ready. It's the best part of the day. So, what did the duck say to the comedian? What did the duck say to the comedian? Well, he said, "You quack me up." And you know what else cracks me up? Solutions of an equation in two variables. Okay, it really doesn't crack me up. It's not that funny. But let's take a look at solutions of an equation in two variables. In order to determine whether or not an ordered pair is a solution to an equation that has two variables in it, right here, this statement says it all. It's all there. If a true statement results when the numbers in that ordered pair are substituted into that equation that has two variables in it, then the ordered pair is a solution of the equation. Remember, in math, everything's looking at truth. Or in other words, we want truth. So, in order to determine whether or not this ordered pair is a solution to this equation, we're going to take this ordered pair, we're going to plug it in here, remembering that this is the x-coordinate, this is the y-coordinate. So clearly that would mean take this number, plug it in for the x, take this number, plug it in for the y. We're going to follow that order of operations, that PEMDAS, and then once we follow that order of operations, if it results in a true statement, truth being that this side and this side are the same, then yes, it's going to be a solution to that equation. If it's not true, in other words, a false statement results, then no, it's not going to be a solution to that equation. And it is that simple. So in this example, it says we're going to do that. Is this ordered pair a solution to this equation? Well, let's try it out and see. So if this is my x, then that means I'm going to plug that x in here. And we know that sitting beside each other indicates multiplication. I'm going to plug the y value in for here at a -4. And now I'm going to follow that order of operations. The PEMDAS says that this multiplication and this multiplication needs to come before this subtraction that's right here. Multiplication, division come before addition and subtraction. So when I multiply 2 times 0, I get 0. And when I multiply 3 times -4, I get a -12. And then subtracting a negative is really adding a positive, and 0 plus 12 is 12. Or we could also look at it as -3 times -4 is a positive 12. Either way is going to be fine. 0 plus 12 is the ending result, and we get a 12 out of that. Is this a true statement? Well, it says 12 is 12. And yeah, 12 is 12. 12 is always going to be 12. So this is a true statement, and when it is true, that means yes, that ordered pair, this one right here, is a solution to this equation. Now, we need to understand that that is not the only solution to that equation. There are lots of other solutions. Because let's say, for instance, that the x was a 3. Well, 2 times 3 is 6. And let's say that the y was a -2. Well, -3 times -2 is positive 6. 6 and 6 is 12. So a 3, -2. 3, -2 would also be a solution to the equation. So there's lots of solutions. We're just saying that this is one of those solutions. And again, the whole idea here is these are called ordered pairs because order matters tremendously. And so, like I said before, this is the x-coordinate, this is the y-coordinate. Mathematicians really do try to make it easy. It makes sense that it would be in alphabetical order. That x comes first in the alphabet, not first in the alphabet, but x comes before the y in the alphabet. And the order matters tremendously. A -4, 0 is not going to be the same point on the 2D coordinate plane as a 0, -4. So the order makes a huge difference. Now, let's take a look at a couple other notions with this. So in this example, it says we're going to find 5 solutions of each of those equations. Now remember, I told you in the previous one that 0, -4 was not the only solution. There were lots of others. We were just checking on that one solution. This example says, hey, we're going to come up with 5 solutions. There's lots of them, and there's more than 5. We're just going to come up with 5 of the multiple solutions. So remember, in this relation, in this equation, what's going to happen is I'm going to plug a value in for that x, and when I do, order of operations says let's multiply it by that 3 and then let's subtract a 4. When I do all that order of operations, it's going to spit a y value out. That will create the ordered pair x comma y. So in order to find 5 of these solutions, what's going to happen is I'm going to say, well, let's choose something for that x, And when I do, I'm going to plug it in for that 3x minus 4 that I see right here. When I do, it's going to spit a y value out. That's going to give me an ordered pair, x comma y. And so what happens here is it says, okay, this is the process. And notice that I am not restricted. I'm not told what to use for those x coordinates. I can pick anything I want. Now typically the good idea here is eventually what's going to happen is I'm going to plot these points on that 2D coordinate plane. So what I'd like to happen is I'd like to see what's going to happen over here, what's going to happen over here. So it's a good idea to pick a couple of the negative x's, a couple of the positive x's, and let's go ahead and pick that 0 right here at the origin and see what happens. So couple of negatives, couple of positives, and the 0. So if I'm going to pick a couple of positives and I'm not told what to pick, I'm going to make my life easy. I'm going to pick some easy numbers to work with, like you see right here. And on that negative side, again, I'm going to pick some easy numbers to work with, like you see right here. So what this tells me is I'm going to make the x a -2. That means I'm going to put a -2 right here. So when I do, and I follow that order of operations, it says, let's do this multiplication, then let's subtract a 4. So 3 times -2 is -6. -6 minus 4 is a -10. That gives me the ordered pair, -2, -10. Very important that we understand that what this indicates is not only does it indicate that -2, -10 is one of the solutions to the equation, but it also establishes this idea of a relationship. And it says in this particular relationship, because of what is established here, when the x is a -2, then because of that order of operations and the relations that's there, the y will become a -10. When an x is -2, the y is a -10 because of what is established there. So let's try out that -1. Do the very same thing with it. Plug it in. Follow those order of operations. We'll multiply first. 3 times -1 is -3. -3 minus 4 is a -7. So in this case, when the x is a -1, the y is a -7, giving us another one of the possible solutions to that equation. And again, because of this relationship that has been established, in this particular case, when the x is a -1, the y will become a -7. So now let's try it for the 0. Plug that 0 in. 3 times 0 is 0. 0 minus 4 is a -4. So that gives us the ordered pair 0, -4. Another of the solutions to that equation. And again, because of the relationship that is established here, when the x is a 0, the y comes out as a -4. So let's test it out for 1. Now a lot of people will think, okay, all I did here was change the sign on that -1, so surely I just changed the sign on this. Well, let's see what happens. When I multiply here, 3 times 1 is 3. 3 minus 4 is actually a -1. Notice it did not change the sign on the answer. So we have to be very careful about that. Go ahead and follow the order of operations. Go ahead and evaluate it. So here is another one of our solutions to the equation, 1, -1. And now let's follow up with the 2, and we found out that that doesn't mean just because we change these signs, it's not going to change this sign. The answer may or may not be a +10. Chances are pretty good it's not. So we'll multiply. 3 times 2 is 6. 6 minus 4 is going to be a 2, and it's not that 10. And so the last of our solutions, not all of them, there's more than this, but the last of the 5 solutions based on the x values that we chose is going to be that 2 positive 2. And again, these are based on the relation that was established here. And I keep pointing that out because watch what happens. We have a new relation down here. This equation looks different than this one. Yeah, both of them multiply and then subtract, but we've got different numbers in there. So the same idea is going to happen here in terms of finding 5 of those solutions. We're going to say, well, let's pick some values for x, and let's plug them into this relationship, -3/2 x minus 2. Once we do the order of operations, that will spit y values out, and that will give us ordered pairs x comma y. So now what we're going to do is we're going to say, okay, let's pick those values for x. And like I said before, good idea to pick a couple of positives, a couple of negatives, and that 0. But watch what's going to happen here. Whatever I pick for this x, when I plug it in here, notice that it's going to be multiplied right here, and we're multiplying fractions. Oh, there's that gang symbol. Remember, when you multiply fractions, you cancel on those diagonals. So what's going to happen here is whatever I plug in here, it's going to cancel with that 2. And again, I'm not told what I have to pick. I'm not restricted, so I can pick anything I want. So I'm going to make my life easy. I want to find something in here that's going to cancel with that 2. Because let's think about this. Let's say that I pick a 1. Well, if I put a 1 in here, it's not going to cancel with the 2. I'm going to get a -3/2, and I'm going to have to subtract a 2. I'm going to retain a fraction in there, which is not bad. I mean, we can work with fractions. We've done a whole chapter on that. We're good at fractions. But I want to make my life easy. So I'm going to pick numbers that will cancel with that 2. Like, for instance, if I put a 2 in there, the 2's will cancel, and I'll get rid of all the fractions. And that's going to make my life easy. So that means, how about a -2? Sure, when I put a negative in here, I'll retain that negative, but the 2's will cancel, and that's good because that's going to help me with my numbers, just making life easy on me. So what else would cancel with the 2? Not a 3, but oh yeah, a 4. So basically, any even number will cancel out with that 2, so those are the types of numbers that I'm going to pick. So how about a -4 then? So here are the 5 x values that I'm going to choose, and I'm going to do what I did before. I'm going to plug them in, and I'm just going to follow that order of operations, and I'm going to see what spits out. So when I plug this in here, notice that, yep, sure enough, these will cancel. 2 goes into 2 once, 2 goes into 4 twice, and so what I have here is a -3 times a -2. -3 times -2 is +6. +6 minus 2 is 4, giving me the ordered pair -4, 4. So there's the first of my 5 solutions to this equation. And again, notice here, this is establishing that relationship. Because of this relationship, when the x is a -4, the y will spit out to be a 4. So now we're going to test our -2. Now notice in the previous relationship, when that x was a -2, we came up with a -10 for our y value. Let's see what holds here. Now once again, the 2's are going to cancel, and they'll cancel out to be a 1. They'll cancel completely. So what I have is a -3 times a -1. -3 times -1 is a +3. +3 minus 2 is just a 1. And notice that I did not get that same y value here because the relationship had been changed. Based on this relationship, when the x is a -2, the y is going to come out to be a 1. So let's test out that 0. And once again, in the previous relationship, when we plugged a 0 in there, we got a -4. Let's see what happens this time. Well, anything times 0 is 0. So that 0 minus 2 will give me a -2, giving me the ordered pair of 0, -2. Notice in the previous relationship, we had a 0, -4. So once again, because the relationship has been changed, now my ordered pair is 0, -2. So I have 3 solutions to this equation. I'm going to get 2 more. So I'm going to plug that 2 in there, and again, follow the order of operations. So I'm going to multiply first, and notice here the 2's are going to cancel. So I have a -3 times 1. -3 times 1 is -3. -3 minus 2 is a -5, giving me the ordered pair 2, -5. And notice in the previous one, when I had an x of 2, I got a y value of 2, not a -5. So one more illustration of the fact that the relationship has changed that ordered pair, and changed up the result. So now let's test out our +4. And when we plug that in there, once again cancels. 2 goes into 2 once, 2 goes into 4 twice. So I have a -3 times 2 is -6. -6 minus 2 is a -8, giving me the ordered pair 4, -8. And again, because that order matters, then that gives me the solution of 4, -8. And so there are the 5 solutions to that particular equation and that relationship. So hopefully this helps with the idea of determining what is going to be a solution to the equation. And the whole idea here is order matters tremendously. The ordered pair simply means that the first coordinate, being that x comes before y in the alphabet, then the first coordinate is going to be your x coordinate, the second coordinate is going to be your y coordinate. And all you have to do is plug those into your equation. And again, everything here is based on truth. If you come up with a true statement, yeah, it's a solution. But if you come up with a false statement, no, it's not a solution. I hope that helps. Have a great day.